Hello guys. We did a project on the travel salesman problem using ACO algorithm. In the next 5 minutes, we are going to discuss that. So let's discuss what is the problem. As we know, in nowadays people are referring online shopping instead of offline. So because of that, courier services and transformation was increased. And day by day, price of gas also increasing. So to ship on time and also for more profit, they have to use less gas as much as they can. So for that they have to find the shortest path. Now let's see an example. Suppose a salesman had an order from places A, B, C, D and E. So by the graph theory, there are many paths possible between 5 nodes. So the salesman has to choose the shortest path to get benefits. So for finding the shortest path there exist many solutions. For example, brute force approach, the nearest neighbor method, the branch bound method, and the ant colony optimization algorithm. Now let's discuss the ACO algorithm. In this algorithm, there are 2 operators. The first is pheromone update measure and the second is trail evaporation. And it has 3 control parameters. The first is number of ants, the second is pheromone evaporation rate and the third number of iteration. And there are many applications of this algorithm, for example TSP, job shop scheduling problem, vehicle routing problem, the dynamic problem of network, quadratic assignment problem and many more. Let's understand the ACO algorithm with a practical example. Let's assume there are 3 ants and they have to go for collecting their food from the food source. And here 3 ants can go in 3 different ways. As you can show, the middle one can go faster and also return faster than the other ones. And that process happens repeatedly. So because of that, middle can make more rounds than other ants. So that path has more pheromone level than the other paths. And all ants will choose their path accordingly to the pheromone level. If a path has the highest pheromone level than the other path, then it would be the shortest path. Let's see mathematical implementation. We used equations for defining the distance between 2 cities and random cities in which ants can travel. And for measuring the pheromone level, we implemented code using these equations in Java language. Now let's see the simulation of our code. As you can show, by the time the shortest path's pheromone level is increasing and ants also preferred to go on that path. And end of the process finally we can show the shortest path. Now let's see the implemented code. Here we implemented the code in 3 parts. We run and write our code in Eclipse. Let's understand the output. Here we have to enter the number of trails, alpha, which means pheromone importance, beta which means distance priority, evaporation factor, Q which means pheromone left on and per trail, and factor, random factor, number of iterations, and number of nodes. As you can show, we use the concept of matrix for implementing the graph. And here in every attempt we are getting the same best length and best tour order. So that tour order will be the shortest path. I hope you enjoyed this video and these 5 minutes have been informative for you.